Great. Welcome, everyone. I'm going to start recording. Actually, I think it has already started. Just going to do a very short intro, and then Harry will start the presentation and the demo. Okay. Hi, everyone. Thanks for joining today. We're going to give people a couple of minutes to join, so just hang tight. We'll get started soon. And we can get started now, actually. I'd like to thank everyone who is joining today. Welcome to the CNCJ September event. My name is Meralda Wu. I'm the co-organizer of CNCJ. Today, we have Harry joining us, who will be giving us an introduction on Kubeflow, a project that recently joined the CNCF family. Before we get into it, I have to mention a few key housekeeping items. Firstly, the session is scheduled for 45 minutes. The technicality rating of this talk is 3 out of 4. The talk is quite technical, and you might be hearing a little bit of Kubernetes jargon and a little bit of machine learning lingo, so strap in. But if you have any questions, please, you can post it in the chat, but please keep them on topic. As to not disrupt the session, Harry will answer all of your questions during the Q&A section. We will try and make this session as interactive as possible, so you will definitely get a chance to speak. You can also ask your questions again in the chat panel, and I will be monitoring the chat panel. This session is being recorded and moderated, so please be respectful towards the speaker and your fellow participants. You will be kicked out if you do not abide by our code of conduct. The session will be available on YouTube under the official CNCF community YouTube channel over the next 2 days. With that, I will hand it over to Harry to kick off today's session.
Cool, awesome. Yeah, thanks, Meralda. Yeah, welcome everyone. Yeah, thanks for joining us. When I was preparing this presentation, I realized that Kubeflow is a huge topic to talk about. It's got like both machine learning components as well as like heavy Kubernetes, basically expertise required to understand it. So what I decided to do is to make today's session just a very brief, I would say like shallow intro into the various components of Kubeflow. But I will focus a lot more on the Kubernetes side of things. And if folks are interested in learning more about the Kubeflow, the machine learning data science side of things, just let me know. I can set up another talk to dive into that portion of the entire ecosystem. Okay, so cool. Yeah, we're here today to talk about Kubeflow, which is the MLOps platform on Kubernetes. Just a quick intro about myself. So I'm the co-founder and CTO at Melio AI, and I've been in a DevOps space since forever, it seems. Ever since the word DevOps became cool, I was in there. And nowadays, I help organizations adopt DevOps practices and implement cloud-native technologies by evaluating and navigating the cloud-native landscape. So I've been working with Kubernetes for over 5 years now. So I'll call myself a veteran. I'm also a certified Kubernetes administrator and a certified Kubernetes security specialist. I'm the CNCF ambassador for South Africa, alongside Lukonda. If you know him, fantastic guy. So I've been trying to push the CNCF and open source message for the past 4 years. And as you know, I'm also the organizer for our meetup event. Cool. And just quick 2 words about Melio AI. We are an MLOps consultancy specializing in machine learning and DevOps practices. We help data science teams build and deploy machine learning solutions, making sure that they are reliable, efficient, secure, and with a specific focus on reproducibility and ensuring that the business gets the return on investment for all of the data science initiatives that they embark on. And we do it both on cloud first, as well as do it cloud natively. Cool. All right, so let's get into today's talk. So the agenda for today will be on Kubeflow, and just a brief intro into the various components of Kubeflow. The entire talk will be about 25 to 30 minutes, and then we'll do a quick demo of the entire Kubeflow platform, which will go through the Kubeflow user interface, some of the use cases. So we'll interact with the actual Kubeflow platform to see what it can do, and then we'll do a little sneak peek under the hood of the entire platform, just to see what it looks like from the Kubernetes perspective. All right. So the entire talk will be about just under 40 minutes. So the rest of the time, we're welcome to just have a more interactive discussion about what this tool can do for both DevOps engineers and machine learning engineers. Okay, great. Cool. So what is Kubeflow? In one sentence, you can grab this from their website. It's an open source platform that can be viewed as the machine learning toolkit for Kubernetes. And it was first announced at the KubeCon North America 2017 conference. And the first version, 0.1, was actually released in 2018. So it's actually quite a mature project. It's been around for 5 years and it's quite popular. And it recently joined the CNCF family as an incubating project, recently as in two months ago. So that is quite recent. And what it actually does under the hood is it leverages Kubernetes to build scalable MLOps pipelines to orchestrate complicated workflows. So it's quite a complex sentence, I know, but yeah, we'll dissect that in a bit. And what is cool about Kubeflow is that it's actually made up of various components, okay? And in the agenda page, there's quite a few that I've listed there. And the benefit for having this entire platform being composed of various components is that you can switch things out and switch things in if you want. And because of that modularity, it doesn't really provide you with like a opinionated architecture or like force you to actually follow its own pattern. You can actually mix and match to whatever suits your team, your organization, or even yourself. Okay, so let's talk about the Kubeflow components. So just a quick overview, it's made up of these main components. There are others, but these main components already capture the entire machine learning lifecycle. So all the way from model development to actually orchestrating the workflow, to training the model. You can actually use AutoML as part of that training, all the way to serving that model. Okay, so you can see that it actually captures the entire flow from start to finish. So it does that by using these top components. And we'll go into the first one now, which is the Kubeflow notebooks. Okay, so the Kubeflow notebooks is specifically used for model development. It supports JupyterLab, RStudio, and recently it supports Visual Studio Code. So you can actually install your own VS Code server as part of this entire setup. And if you just go to their website, you'll see it supports these three. And basically, you can actually let me just make this smaller. Yeah, you can actually access the cluster remotely. So which means that you can actually do any remote development work without having, you can actually keep your computer as a thin client and use the cluster itself if you're trying to do something like super heavy, like you try to use like 64 gigs of RAM, etc. So you don't actually have to own that machine. So that's one big benefit of it. And with the recent announcement of having support for VS Code, it actually makes it a lot easier and more flexible for people who actually don't just want to do machine learning workloads. And then the access control is managed by RBAC. So for folks who are familiar with Kubernetes, behind the scenes, it actually uses SDO to actually manage a lot of the auth, which is actually good. And it also enables sharing of these instances within the team. So you can have multiple users using the same instance, which for teams, it's great. Okay, cool. And then, so that's it on model development. Next one, on orchestrating workflow. So workflow in the machine learning world, or specifically in the Kubeflow world, it's basically a directed acyclic graph. Okay, so it's just a whole bunch of blocks and arrows linking together. You can't have arrows going back, but it's just in one direction, and it can split, it can join. All right, and as you can see, it allows you to actually mix and match a lot of complicated components, and then we'll go into what a component is. So yeah, various components linking with these arrows creates pipelines. So if we actually look at the definition of it, you can actually interact with it via the API. It gives you this nice GUI that you can visualize and see the status of each component as it runs. But you can also interact with it via its own SDK. And then there are like various benefits for using Kubeflow pipelines. So I think the most significant one is the ability to actually run a lot of these tasks, either in sequential, parallel, but backed by the power of Kubernetes, the ability to scale up and down without you having to worry about it. You basically just define how much resource each component needs, and then behind the scenes, it will go and provision resources for you, utilizing Kubernetes, like a lot of the auto-scaling plugins and capabilities of Kubernetes itself. All right. So yeah, we'll have a look at what this pipeline looks like and the niceties that you get from using Kubeflow pipelines. Okay, so that's it on workflow orchestration. Next up is on model training. So this, to be honest, I haven't used a lot of. So a lot of the work that we do, we actually have custom training that we actually don't need to use training operators. A lot of the times we actually write our own Docker images to actually do training. But out of the box, Kubeflow supports these different types of models. They call them jobs. Okay, so you have like TensorFlow jobs, PyTorch, MXNet, XGBoost, etc. Okay, so these are the ones that is currently being supported. So what is cool is you can actually schedule these trainings, okay, and it's very synonymous with Kubernetes cron jobs or jobs. Okay, so it's very similar to that. You can also have multiple replicas if you're into that, running parallel with each other, etc. Right. So it's just an easier way to actually train your models without you having to custom write a lot of boilerplate code. You can just just use something off the shelf, write some YAML files. You'll see that it actually uses its own type of CRD, and then from that you can actually specify some of the parameters that you're looking for. Is this do you actually need a GPU or not, etc. All right, and you can put this on the schedule, which is super useful for those monthly runs, weekly runs, or even daily runs. Okay, so that's it on training, and then again we'll go into the using the GUI just now, just to have a look and see what it looks like under the hood. Then next is a project called KTIB or KTIB. I'm not really sure how to pronounce it. It's an AutoML framework that is a part of the Kubeflow project. I think at some point they're probably going to break out of the Kubeflow ecosystem and host it themselves. But right now it's lumped together with Kubeflow, and basically it's just a tool for machine learning engineers to do hyperparameter tuning and this neural architecture search. Okay, so I'm not a machine learning engineer myself, so a lot of this stuff is like over my head, but it allows you to tune your models, especially like deep learning models, where you actually have to pick the correct parameter that can optimize specific model metrics. So it does that by using these two things. It's got various strategies that it uses. different algorithms. As you can see here, there's Bayesian optimization, there's random search, of course, and then there's all the other fancy stuff. And what it actually looks at is a lot of the times out of box, it looks at learning rates, number of layers that you want, number of nodes in each layer. So these are very specific and more applicable in deep learning type of models. And it will just iterate through various parameters, okay, between the specific range, kind of like a loop. It just goes through it, but it's more complicated than that depending on algorithm that you select. And it gives you this fancy graph to see all of the iterations that it has gone through. And then from that, it will actually pick the best one. And yeah, we'll also have a look at what that looks like just now. One thing worth mentioning is throughout the documentation, you'll see each of these components will have a stability. So it's either, I think, alpha or beta. So alpha is just something that they basically rank that it's still new and there could be some weirdness to it. So use at your own risk. And some of the components that are in beta is safe to use, right? So if we look at Kubeflow pipelines, I think you'll see that I think V2. Okay, so it doesn't say, so this is safe to use. I just want to see if I can show you one that has, stable, and there should be one that actually shows you that it's beta. Okay, stable, right. Okay, but you get the gist of it. So alpha ones are like components that could subject to change in their API and the way you structure things. So between major versions, you actually might have breaking changes introduced. So yeah, so you use them with caution. Okay, cool. So that's it on AutoML. So this is a very machine learning engineering type of tool. Then next up, model serving. So once the model has been trained, it's got to be hosted somewhere. So there's this project called KServe, which actually originated from Kubeflow project itself. It's actually used to be called Kubeflow KF-serve, Kubeflow serving. And then I don't know the reason why, but they broke out and decided to be their own project. So you can actually install KServe in standalone mode. So again, back to what we're saying, that it's modular, that you can actually mix and choose. So if you decide to use another model serving tool or framework instead of KServe, you can actually just pull it out. But yeah, KServe is fully compatible with Kubeflow. So that's why it's a lot of the times when you install Kubeflow, KServe will probably come with it. But these days, they also support other frameworks, such as Bento, and then Selden as well. So Selden is a big contributor of KServe. The models that KServe supports, just to name a few, is TensorFlow, XGBoost, Scikit-learn, Torch, and Onyx, which is a good format that people go for these days. But it supports a few more. But yeah, if you just go to their website, you'll be able to see all of the models that they support. There's an entire list on it. Yeah, so you'll see here. So this is a full list of everything that they support. Let me zoom in a little bit, maybe. Okay, cool. So this is it. All right. So KServe is super powerful. So under the hood, you can see that it actually uses a lot of cloud native technologies. It's kind of interlinked with Knative. Okay, so it's just a serverless layer for Kubernetes, and it runs on top of Kubernetes. So it's like Knative plus SDO. So it's actually quite involved. But yeah, if you're interested, we can also take a look at what that looks like inside the cluster. Right, cool. So that's the model serving portion. All right. And yeah, so we just saw the various components from model development to model training all the way to model serving. So Kubernetes can be thought of as an MLOps platform. Sometimes MLOps platform captures a lot more than what I've just described, because there's also maybe data operation such as model monitoring, etc. there is the concept of, for example, a lot of like DevOps tooling also has it, like approval processes, a lot of the gatekeeping, continuous delivery or continuous deployment processes. So what we're talking about now is just the tool. So we haven't talked about processes. So, but a lot of MLOps platform will actually also suggest what those processes should look like. So they're more people, team focused, whereas Kubeflow, because it's modular, you just treat it as a piece of technology that you can use however you want. Right. So just to look at some of the other MLOps platform options. So I've selected two other ones, so AWS and MLflow. So basically another open source project and a cloud first, cloud provider based ecosystem. So, and then I basically have a few categories that I use to actually do the comparison. So we can go down the list. So the first one is the infrastructure provider. We know the Kubeflow based on Kubernetes, it's cloud native. So it doesn't matter as long as you have some VMs, you have some servers, whether it's on-prem or cloud, you can run it anywhere. AWS, of course, you got to run it in AWS. MLflow is the same thing, right? On-prem or cloud. Then on the category of feature store, Kubeflow, they do have a few suggestions, Feast being a big one. So Kubeflow itself doesn't come with a feature store. So that's also one thing that it's missing, but it does have a nice inside its own documentation, how you can actually introduce Feast into it. So you'll see that over here, it says external add-ons, okay? So it's very different to the core components that we just went through, because these can be considered as external projects, and the Feast being one. So even though I think people normally choose Feast if they want a feature store for Kubeflow, but yeah, you can choose whatever other feature store you want, because you can mix and match. And again, this integration or this project itself, the compatibility with Kubeflow is in the alpha phase. So again, use with caution, right? So for those of you who don't know what a feature store is, it's just a way for people to share and reuse features, okay? And the features are just these variables that you get as inputs. After some cleaning, after some pre-processing, you use these features as inputs into training your machine learning model. So there's a lot of benefits for using something like a feature store to store these features. And the most important thing is this sharing and reusability. All right, cool. And some more advanced feature stores also offer this consistency between training and serving. All right, so basically you would use the same script to do your data pre-processing, as well as do a lot of on the fly transformation of these features into an input for your machine learning model. So yeah, cool. And then on the AWS side, AWS itself has Amazon SageMaker feature store. Okay, so Amazon SageMaker is AWS's own entire MLOps platform, and itself is also made up of various components, and they also have their own feature store to store features, and it's tightly coupled with the rest of the ecosystem. So even though you don't have to use the feature store that comes with Amazon SageMaker, you can actually replace it with Feast. But yeah, it is a little bit difficult to actually do that. But Amazon SageMaker feature store by itself, I've never heard anyone use it by itself, but normally you actually use it within the context of the entire Amazon SageMaker ecosystem. And the MLflow, if you go to their webpage, they also talk about Feast integration. So MLflow themselves don't have the feature store. All right, cool. I also realized that I'm speaking about MLflow as if everyone knows about what MLflow is. So MLflow is also another MLOps platform, but it's less platformy. You can think of it as a more project-based, more like a library, and it gives you an opinionated framework to actually train, build, and then deploy your model. And then, yeah, we can actually have a look at it just now. Okay, cool. And then on experiments tracking, Kubeflow pipelines has the ability to track the experiments. So every iteration that you do, so as data scientists, a lot of the times you would try many different things with data as part of EDA or exploratory data analysis, or you just want to try various inputs, various features to train a model. All of that is being tracked by Kubeflow pipelines with behind the scenes metadata integration. So Kubeflow has its own metadata track, and then you can actually integrate Kubeflow pipelines with that to keep track of what experiments are you running, what data was actually used in that experiment, what was the output of that experiment, etc. In AWS world, you have Amazon SageMaker pipelines, which does the same thing. It looks very similar to that DAG that I just showed you with those blocks, with those arrows. MLflow comes with MLflow tracking, and MLflow is quite famous for that, for this experiment tracking. This is super powerful. If you're interested, you can also take a look. All right. On notebooks, so we're talking about model development. Kubeflow has its own Jupyter Hub, as we saw. It supports Jupyter Lab, RStudio, as well as VS Code. AWS has this amazing Amazon SageMaker Studio. So we use it a lot these days, and the GUI is amazing compared to all of the other GUIs that we have seen. So it resembles, if you're familiar with how Jupyter notebooks look like, it resembles that, but it's got like a lot of additional functionalities. MLflow itself, yeah, it's not really opinionated. It doesn't give you any modules for the notebook. You can use whatever IDE or environments that you want. SDK, all three supports SDKs. You've got KFP, pairing. So these are just clients that you use to interact with the various components of Kubeflow. AWS, Flutter3, MLflow, it's also got its own clients. So that's cool for all three. From an AutoML perspective, Kubeflow, we just saw that there is that neural architecture search, as well as hyperparameter tuning through Knative. AWS, you've got the AWS SageMaker Autopilot for the AutoML stuff, and the MLflow, again, no, doesn't have. But again, it's not opinionated, so you can use whatever AutoML framework that you choose. Yeah, I don't know if you can use Knative with MLflow. And then on the machine learning metadata store, I mentioned, you normally use Kubeflow pipelines with Kubeflow metadata, which then gives you that nice lineage. On Amazon, on AWS side, the Amazon SageMaker feature store actually gives you that as well to track that lineage. SageMaker pipelines out of the box already gives you that lineage just because of how coupled the entire ecosystem is. It's quite easy for them to track that. But for Kubeflow, because of the nature of these modular components, it is people frequently just don't use the entire Kubeflow thing. They might switch out Kserve for Seldon. They might switch out, they can actually switch out some of the Kubeflow pipelines capabilities for MLflow. But because of this switching out, it's very difficult to keep track of that entire lineage. So a lot of the times you actually have to kind of write your own code to integrate with the Kubeflow metadata. Kubeflow metadata actually got renamed to Google's ML metadata. So I think it's just a rebranding, but under the hood, it's the same. I'm not too sure. But I think the API is still the same. It's still consistent. We can have a look at what the lineage looks like from the Kubeflow side of things just now in the demo, right? And then on pipeline orchestration, talk about Kubeflow pipelines. And then SageMaker has their own SageMaker pipelines. It's more or less the same. MLflow, on the other hand, doesn't really do pipeline orchestration in the sense like of a DAG. You can incorporate it as part of a workflow of a bigger project, but because itself is more like a library, like a tool, like a service that you use. So it's not like this massive piece of system that you can use it to orchestrate workflows. If anything, you actually use it as part of your massive workflow, right? And then model serving, we mentioned Kserve, but if you actually check Kubeflow's page on model serving, you'll see that there is also a lot of tools that is compatible with the Kubeflow platform. So I mentioned Seldon. So Seldon Core is a very popular one. It's got stable status, so good to use. Bento ML is a new one. So we did some investigation on it. It's actually very, very promising, and it does one thing really, really well, which is this serving. And the way it packages is a little bit different, but it makes sense, you know. So if you're interested, also look at Bento ML just purely for model packaging and model deployment. In terms of open source, Bento ML itself is open source, but I think recently the GUI, this very awesome GUI that they have to just give you a glimpse into the model registry as well as the model deployments is not really open source. So again, use it at your, yeah. And then ML Run is another one, Triton, TensorFlow Serving, etc. All right, so these are the ones that Kubeflow support. So you don't have to use Kserve, right? You can actually switch it out, and it's quite easy with these ones to switch out Kserve, yeah, with these other tools. SageMaker itself comes with endpoints, and then MLflow again. It's also a very, very powerful components of MLflows, which is this MLflow models. Okay, so it actually is also a way for you to package models. If you work in the MLflow ecosystem, various teams can literally exchange those models just because of that format that they have, that packaging that they do. All right, cool. On model monitoring, so we're talking about what happens after the model has been deployed and it's been hosted. From Kubeflow's perspective, Kubeflow doesn't have itself a model monitoring component, but you can use a third-party one like Seldon Alibi. What I should have done is put an asterisk here, but yeah, Seldon Alibi is not part of Kubeflow, it's part of Seldon. But yeah, this is also cool for monitoring. And then Seldon also has other tools for explainability, for adversarial attacks, etc., which you can also use for what happens after model serving. Okay, so you can use the entire Seldon suite of application. And Seldon itself is Seldon Core is open source. They've got their own enterprise managed service that they charge for. Amazon SageMaker comes with monitoring built in, so you can actually just enable it. Yeah, it's also quite simple. In terms of making it do what you want it to do, that's a little bit involved, but yeah, it's along the same lines. I mean, it's the data is all there, either in CloudWatch or whatever. All right, and then MLflow model itself, as part of that, as you call it, it actually produces logs that you can use for your model monitoring. And then the last one over here is model registry. Okay, Kubeflow, I mentioned that lineage. You can think of that as a way to track the model's movement from development all the way to deployment. Use that metadata store, but itself doesn't really have a model registry in a sense. So Kubeflow stores models, it stores artifacts on S3, all right, or any S3 compatible storage. So in that situation, just basically does the storage, and all the metadata along that storage gets stored in Kubeflow metadata. And if you look at it from that lens, it actually looks like a model registry. All right, so that's why I put Kubeflow metadata here. From AWS side of things, you've got SageMaker model registry, which is its own nice database. Also very similar. It's metadata linked with S3 storage. Okay. And then MLflow itself also has a model registry. Okay, so this one is, I would say, a lot more involved, but again, it makes sense if you've packaged the models using the MLflow model mechanism and then put it in there. It also tracks it quite nicely. So you can see that, so this is just the other tool, the other two platforms or ecosystems that I've used to compare, but there's a lot of third-party MLOps platforms out there these days. You can just like go to Google and just type in MLOps platform, you'll see a myriad of them come up. So, you know, Neptune AI is one of them. Velohi is also a big one these days. There's also people who's doing managed Kubeflow, Orocto being one of them, but they're not around anymore. But yeah, so there's actually quite a few companies out there that's doing a lot of MLOps platforms. So it really depends on what you want. So if you're keen on learning about, and you want to make sure that your stack is open source, that is part of the Linux Foundation, etc., you can just go for Kubeflow and all these ones that they support. If you just want to go the simple routes, maybe just, you know, you're one-person team, you want things to be like done quite quickly, and you don't mind the cost, then go AWS. So mentioning of cost is actually quite interesting because, yeah, AWS, right, SageMaker is not cheap, right? But if you actually look at the time that you spend learning about Kubeflow, all that investment that you put in, and you convert that to I don't know, your salary or something, maybe it actually is more than AWS. So sometimes you can look at it from that light and see and do that comparison. Yeah, so even though Kubeflow and all that stuff is like free and open source, but that investment that you put into it, a lot of the times could be a lot more than just using something off the shelf. All right, cool. So that's it on that. And before I go into the demo, are there any questions? Okay, I see Matteo has a question about how does MLOps differ or evolve with LLM? So that's an interesting one because I used to think that it's not that different. And so I started looking a little bit into it and then chatting to folks who are in the space, and I realized how different it is. Because some of these, for example, this typical machine learning lifecycle may not be directly applicable. I think from a principle perspective, it's the same, but the tooling that you use is actually quite different. But yeah, I mean, if you're interested, we can chat more about it afterwards. But yeah, again, I'm not a machine learning engineer. I don't know the space like well enough. But yeah, I feel like it's a lot different because now you have to think about vector databases, like fine tuning, and a lot of the times, like maybe you're just better off wrapping something that's already there. But if you actually want to host your own, like how do you actually host it? Because a lot of the times, like these large language models are like hundreds of gigs, right? Which then is quite significant compared to like the usual models that we deal with. Which is like maybe 100 megabytes, just a few gigs maybe, but then we're talking about like hundreds of gigs, and then the way you manage it will be different. Yeah, cool. Is there any other question? Yes. LJ asks if there are any integration between Kubeflow and AWS SageMaker. Yes, there is. So if you go to Kubeflow on AWS, there's actually a massive section on that. So I can just quickly show you. But yeah. Yeah. So Kubeflow supports a lot of cloud providers out of the box, right? So such as like Kubeflow on AWS, Kubeflow on Azure, Kubeflow on Google Cloud, etc. Lots of different clouds that it supports. And then what is interesting about this is that Google Cloud itself has a managed Kubeflow service, which is called Vertex AI. But if you don't want to use that service, you can spin up a GKE and you can bootstrap your own Kubeflow on top of it. Right? So that's also one way of doing it. I'm not really sure what the price difference is. Yeah, we don't work on Google Cloud, but yeah, it's just very interesting. Yeah, it's maybe something good to look at. So if you look at more, yeah, you'll see that because it's AWS related, of course, they want to sell you on the SageMaker integration. Because Kubeflow is quite modular, so you can actually switch out a lot of the Kubeflow pipelines components out for SageMaker pipelines if you want. You can trigger SageMaker workloads, SageMaker deployments, endpoints, etc. from Kubeflow. So yeah, I don't know why someone would do this. I really don't find a use case for someone to use both Kubeflow and SageMaker, because if you can use SageMaker, a lot of the times it's a lot easier to just adopt the ecosystem, right? Unless you have like very specific reasons for that you only want to use Amazon SageMaker, but you don't want to touch any of the other AWS products, maybe. But yeah, SageMaker also has this operator, this ACK operator. So the Kubeflow cluster that our demo just now is actually deployed using this way, Kubeflow on AWS, right? So the one that I'm going to show you just now actually utilizes behind the scenes these services. So Amazon RDS for database, Amazon S3 for your object storage, and the Amazon Cognito for auth. Right, and of course backed by EKS. Okay, and then Greg's got a question. Can you use Kubeflow to run non-ML workloads pipelines, such as statistical or data-intensive pipelines that don't need to train a model? Yes. So a lot of the times, people that really need machine learning, or they're actually not building machine learning models. They could be running models, but behind the scenes is actually just like a series of Python scripts, for example. Okay, like you said, like it could be statistical or data intensive. In that case, you can still use Kubeflow pipelines. So a Kubeflow pipeline is built geared towards machine learning workloads, but because of the way it's structured, you'll see that when I said Kubeflow pipelines, I said that it is just a workflow orchestration. Can think of it as an engine even, but it doesn't necessarily have to be used only for machine learning, because behind the scenes, all it's doing is just stringing up various Docker containers as components, as steps, and then the output goes into another step as an input, etc., and just string it like that. And because you're using Docker containers, it doesn't really matter what you actually have in those Docker containers. Yeah. Cool. Are there any other questions? Okay, great. Okay, cool. So yeah, the Kubeflow cluster that I will be logging in is actually bootstrapped using this piece of documentation. So if you just go and just select deployment options, if you just follow along, you can actually see a lot of the cool things that I mentioned. Yeah, so you'll see that they actually give you various options on how you can install Kubeflow. So you can actually select whether or not you just want to use their Cognito, which is their auth service, without using their database or object storage, or in this case that I'm showing you now, we're going to use all three. And it's also got a very nice way of bootstrapping the entire Kubeflow cluster using Terraform. Okay, cool. All right, so that's the Kubeflow cluster. I'll show you. I'm going to stop sharing and share my other browser. Give me a sec. Share my entire screen. All right. Okay, cool. So spinning up Kubeflow is actually quite simple. You don't have to be like someone who knows exactly the in and outs. You can just follow the documentation from that website, Kubeflow on AWS. It's the same with Kubeflow and Azure. They've got very detailed step-by-step. Everything is abstracted away from you. You just run a few scripts, and voila, you get the entire Kubeflow cluster. The thing to note is that with these supported mechanism of spinning up Kubeflow does require you to use the managed Kubernetes cluster from the cloud provider. So Google will be GKE, Azure will be AKS, and then Amazon will be EKS. And that is quite costly. I think, yeah. So you just have to be prepared to pay that when you do follow these instructions. All right, cool. So after you've actually spun up, you can actually go to the domain name that you actually specify. So in this case, if folks are familiar with Cognito, you'll see this very, very familiar interface. So this is how Cognito, so this is actually integrated with Cognito. So behind the scenes, it's actually integrating with AWS Cognito to provide authentication as well as authorization. So I'm going to log in. Hopefully it's not the right password, of course. Wait, hold on. What's this one? All right. So upon logging in, you get this nice dashboard view of all of these various things that you can do. All right. So what I want to do is just run everyone through the GUI. I'm going to zoom in a little bit so you can see. So the various components that I mentioned just now in the slides, we'll go through them one by one. So first is on model development. There's this nice notebook tabs, which allows you to spin up your either Jupyter Lab or RStudio or VS Code, right? So you can click a new notebook, all right? And it will ask you what type of instance you want to spin up. Is it Jupyter Lab? Is it VS Code? Is it RStudio? All of this is basically Docker images that you use, that you're hosting, right? So you'll see over here, it's like, hey, which image do you want to select? In our case, you'll see that I'm using a bespoke image from AWS. I don't know how bespoke it is, like how different it is from a Jupyter notebook that supports TensorFlow and Python 3.10. I don't know how different that is. I don't know what is in there. Never did my investigation, but yeah, you're able to select these images out of the box if you have Kubeflow on AWS, right? Cool. And then there are also various advanced options. For example, people who have Kubernetes knowledge will know what these things mean. It's basically like, hey, do you pull the image always, or if the image doesn't exist on the node, then yeah, or never pull image. So the reason why this is a thing is because sometimes these images could be big, especially ones that have TensorFlow, have like prefig or whatever. These images could be like, you know, tens of gigs, and then yeah, and that has some cost associated with it. But yeah, you can also select your custom image and then you just paste in the actual Docker Hub URL. If you want to do a private registry, you can also do that, but there is a specific way that you have to give the Docker secrets to this entire Kubeflow environment so that you can actually pull from that. That setup is, you can just Google, you'll be able to find it. All right, cool. And then you can specify the resources that you want to give. But this instance, again, yeah, you can give how much RAM, what is it, the vCPU that you want to give it, etc. Right. So one thing to note is you must understand the underlying instance that you're using for this entire setup. So what has happened a lot is that, you know, people sometimes say that I want, you know, 64 gigs of RAM, and then meanwhile the instance type that you've selected only supports maybe 16 gigs of RAM. Then what happens is that this thing will never be created. It will just be stuck pending. All right. You can select GPUs, etc. You can select how big you want the volume to be. So this is quite useful. A lot of the times when you're actually doing exploratory work, you like tapping into multiple data sources, you're pulling data in, all that stuff. You just have to make sure that you give yourself enough volume size so that you can actually do your work. And then there are also specific configurations that you can add. This is just me configuring differently. I don't want to go into details of it, but you can also provide this entire Jupyter instance credentials to access AWS resources. Okay, so naturally, we're running this on AWS, so I gave it some AWS access because I want to use the S3. I want to use the container registry from AWS. All right, and then after you're done, you can just click launch. The reason why I can't launch is because I didn't give it a name. But I say test, I can launch it. All right, but since I've already got two launched, I'll just open one up and show you what it looks like. And yeah, it just looks like normal Jupyter notebook. Basically, it's the same as what you expect. Okay, the good thing is that you know that it's running within your Kubernetes cluster. So by providing it with the correct either AWS credential or Kubernetes credential, you can actually interact with the resources within Kubernetes just from this notebook. And a lot of times you probably have to do it. All right, cool. Okay, so you can open, so I've already pre-cloned some example. So you can go to just type in Google Kubeflow examples and you see a lot of example Jupyter notebooks that you can play around with. So yeah, okay. So as part of the demo, I actually wanted to run this, but for some weird reason, this wasn't working. But yeah, we'll come back to this after I show you the rest of the components. So yeah, you would do your exploratory work, you'll do your model development via Jupyter Lab, which is something that data scientists are not unfamiliar with. People should be quite comfortable with using either Jupyter Lab or RStudio. Next is this tab over here, volumes, which is actually very interesting. I've never really interacted with this, but it's just a good way to just view like what are the volumes that is currently being attached within your namespace. Okay, so to that is, you can see like which thing is using it. So this will also, so right now there's only notebooks that's attached to these volumes, but you can actually attach these volumes to pipelines as well. So let's say if you have prepped some data, right, that you store on these volumes can be shared with the pipelines, with those components to be used. So that's also one way of working with it. I wouldn't call that an anti-pattern. You can do it like that, but a lot of times it's a lot better to just like centralize a lot of the data that has been pre-processed to somewhere, and then you can actually pull it down from there. A lot of times it's also got to do with lineage. You want to just like track that nicely without having it being mixed with your experimentation or your development environment. This one is cool. So right now I don't have any models being deployed, but if you remember, part of Kserve is that you can deploy models. So once a model has been deployed, you actually can actually interact with it from here. You can actually see the resources that it's being used, what type of model it is. So this is runtime thing. I can't show you now because that Python notebook wasn't working, but you can also see where that model has been stored. Right, so that's also like just very, very useful information for you to easily interact with models, and you can see if something is wrong. Next is on Kubeflow pipelines. Okay, so this is very, very confusing. So these three tabs, experiment, KFP, pipelines, and runs, as well as recurring runs, these are all speaking to Kubeflow pipelines. So Kubeflow pipelines is core to Kubeflow. I think, yeah, Kubeflow wouldn't be an MLOps platform equivalent if it doesn't have Kubeflow pipelines. So it's like a very, very important piece of Kubeflow. I don't think anyone would use Kubeflow without using Kubeflow pipelines. You'll probably like either do standalone Kserve or standalone Jupyter notebooks, etc. But if you want to use Kubeflow, the biggest reason will be probably because you want to use Kubeflow pipelines. So there's this pipelines tabs, okay, which actually just gives you a nice overview of all of the pipeline assets that has been stored on Kubeflow, right? So this is very, very useful for reusability. Okay, so what you can do is you create the DAG, you basically link the components, you do all the hard work, and now you can share it with the rest of the team. Okay, so remember we talked about like team sharing and all that stuff. You can actually give people access to see your stuff that you have created, or you can actually expose it globally for everyone to see, but that requires some extra configuration. So you can see that over here, you're able to add contributors, okay? So your team members, and they can either make them owners or contributors, etc. All right. So that's very, very useful for big teams that want to just share assets and share models, data, etc. Cool. Great. So I see that we're running out of time. I will quickly just walk through these ones. So with pipelines, if we go into one of them, you'll see that this is someone has pre-configured and pre-built this pipeline, right? All you have to do in this case is just to create an experiment or create a run. So experiments, you can just think of it as a grouping of runs, all right? So if I say create run, it's going to ask me what experiment do you want to link this to, all right? So we can just choose one, use this experiment, okay? Over here, it's interesting that you can actually run it as a recurring job or once off, okay? And then you get started, right? I've done one earlier, so we can have a look at it, and you'll see that there is nice little visual marks, as you can see, if something has gone wrong or something has gone right. And there are also like conditionals. So if something happens, do this, or if something breaks, then break the entire thing. Okay, so it's got all of the fancy DAGs, DAG operations that you would expect from this type of tool, very similar to how Airflow does it. Okay, one thing to note is that you'll see over here that all of the logs, artifacts, etc., is actually stored on S3, which is actually quite good. So if you don't use S3, you'll probably use the built-in Minio, which is an S3 compatible object storage. But this will be actually stored in S3 forever, and then you can implement some lifecycle policies, etc., over there, right? So you actually don't lose these logs, and this is especially important if you want to track lineage. So if we come and we look at one of the things that we have run, you'll be able to see the lineage. And then the more times you run, you'll see how important this lineage becomes. So the assets that is actually being reused will appear in one of the other lineage tracker. And then you'll see how things actually progress and how they are linked. So this actually comes from how the Kubeflow pipeline is run, all right? So this is just another use case of ours, but you'll see over here that, what is the output artifact, and you can actually see like which step and all of the metadata associated with that run, with that pipeline, and with that component. All right. You can look at the inputs, you can look at the outputs, and this is very, very important if you want to track your lineage. Okay, and then this is all backed. So what I'm showing you now is the Kubeflow metadata, and then through the metadata and linking with artifacts, you get this nice lineage tracking. So this is just a visual representation of things that's already in the database. Okay, cool. And then I wanted to show you the last thing is Kate, which is the AutoML portion of it. I ran it. It took very, very long, but over here you can see that this is just a random MNIST example app that I just ran. Okay, so basically to tell it to iterate through various ranges, etc., and then find the best one. So you'll see that these are the trials that it ran. It did 4 because it normally takes long. The optimizer that it uses SGD, and this is the best one. Okay, so it selected that, right? And it depends on what you're trying to optimize on. You're trying to optimize on, training accuracy, etc. Yeah, and then it'll give you a nice image of this. Yeah, I'm not really sure the significance of this is. We normally just look at this and we look at this. So I don't know why that is shown, but it's just very pretty. Okay, and what is cool is you can actually submit YAML. So everything in Kubeflow is in the form of YAML, just to kind of align with like how Kubernetes resources are. You can actually copy and paste and change these values and resubmit again. Okay, and you can also do that programmatically. And a lot of the times that could be the best approach is you would look at the trials, check it out, tweak these values, right? Because you can see that it actually gives you the results. You can actually write your own algorithm to actually find the next parameters that you want to use for the trial if the output of the trial is not satisfactory. And that's it for the entire talk. Yeah, I went severely over time. I thought it was going to only be a 45 minutes talk, but I think I spoke too much. Cool. Meralda, I don't know if we have time to take any questions.
I'm sure we can. Are there any questions from the attendees? Is anyone still there?
Hopefully I didn't bore anyone to sleep.
Nope, not bored to sleep. All good.
Oh, great. Then if there are no questions, thank you everyone for attending. Actually, Greg has a question on, is there a model registry?
Yeah, so as I mentioned, Kubeflow doesn't come with a model registry, but you can use the metadata to kind of simulate that effect of a model registry. Yeah, but if you just actually want a model registry by itself, Kubeflow doesn't have, but I think you can get off-the-shelf ones. And I see Mateo also has a question. How much does it cost to run Kubeflow in AWS? The cost really depends. There is base cost for running Kubernetes in AWS, for example. So EKS by itself with no nodes is about like $70 a month if you just leave it running. So it's actually quite expensive as a base cost. And then you have the nodes on top of it, then you have to pay for storage and traffic going out of the AWS, etc. So yeah, it becomes quite expensive. Okay, cool, great. Yeah, thanks. Thanks everyone for joining us.
Great. As we mentioned, the presentation will be on the YouTube channel from the CNCF official community channel, and I'll also share the slides in the meetup comments. Thank you so much, everyone. Have a great evening.